Hello, my name is Ramesh Naderwala. I'm the head of R&D at OMIC R&D here in Scappoose. Today we're going to talk a little bit about the importance of blueprints and the steps it takes to create a blueprint drawing. Let's say that you have an idea or somebody has a need to create something in a factory or even just as a hobby. So I'm going to talk to you about the steps that a typical company would go through to manufacture something. So from your mind, you have to somehow put that idea out to communicate it to many people. And typically people first would just draw out something on paper, and then eventually we hope to put it in a computer system. So typically you put the concept on paper and you draw it out or you draft it. After you have some sort of an idea of what was on your mind on a piece of paper, usually what happens is that you sit down with your team or folks in your company and you review it with your peers, your coworkers, and even people who you report to, like your managers. Now what happens usually is they have their own minds, so they're going to come into play, and it's a good back and forth. People are going to ask questions, you're going to give them feedback of what you were thinking, they're going to suggest ideas for improvements, they may raise some awareness that's something you may not have looked at. That's the beauty of teamwork. Some folks may even offer their knowledge from their specializations. For example, if somebody on your team was a material specialist, they may suggest an alternate material as compared to the one you were originally thinking about for strengths or thermal conductivity, things like that. And so what I'm trying to get at is that together we can mature an idea, and most things done correctly are rarely done individually. So teamwork is very important. Somewhere along this discussion or soon after this discussion, this hand-drawn picture will get put into a CAD system or a computer system where you're working towards locking down your idea or your concept before you go into production mode. So even at this point, as you're drawing it in, your team's still with you. You're refining the idea and working ultimately towards a formalized sign-off on that concept. And you're basically starting to get towards the next phase of producibility. So let's say that you have your drawing finalized in the 3D CAD system. Well, it's still a 3D system. Now you need to communicate it to people who are going to produce it. And how do we do that? And the starting point on that is called creating a blueprint drawing. So we're now marching towards the next phase of producibility. And the very starting point of that is to convert your CAD drawing into a formal blueprint. Now, a blueprint is basically the output of a CAD model on a single piece of paper. It can have various degrees of complexity depending on what you're trying to make. Well, are you trying to make a simple toy or a hobby part, or are you trying to make an aerospace component or something that is used in surgeries or in automotive? So that carries with it things like tolerances on your dimensions. How precise do you want something? What materials are to be used? The dates at which it needs to be signed off and produced. The actual sign off of the blueprint to formalize it. It could even have a bill of materials, means all the things you need that are components to assemble this item. And also things like part numbers, so that you really formalized the item you're trying to manufacture. From here on, you're going to observe the OMIC team try to create these hammers. One of the first things you're going to see is a group of OMIC employees get in a room and conceptualize an original idea as a team, and they're going to do whiteboarding.
This rough sketch here, but let's draw it out a little bit more on the whiteboard so we can turn it into a blueprint.
Yeah, so what were we thinking for the head? Probably out of brass.
Yeah, we're going to make it out of brass so it's non-marring.
So we're going to start with a piece of brass stock, and then we will make a hexagon out of it.
Okay.
So that will be our final part.
That'll work.
So kind of just a straight cylindrical rod for the handle itself.
The design continues to be refined. Next, we're going to put this design into a computer system commonly known as CAD, or computer aided design. Here, the designer can turn the object around, refine it, really take a close look at it. In some advanced systems, the user can even incorporate material properties like density and thermal conductivity. But in this case, we're implementing threads and refining our diameters. Once the designer feels comfortable with the CAD model, it can then automatically output a blueprint design, which is a formalized 2D image of the design. And we have various orientations: top view, side view, and even a oblique view. If needed, we can now output a NC program, which is how the design system talks to a machine tool. And here, on some of the more advanced design softwares, we can even simulate the machining of the design. Now that we have the initial design finalized electronically and a blueprint created and some basic manufacturing simulations may even be run, the team now comes together to talk about actually making it. They talk about tools, fixtures, machines.
Okay.
All right. So here are the CAD drawings we came up with. What kind of tools do you think we're going to use to do the brass?
Well, we're going to start with an 1 1/4 brass stock, so we shouldn't need to do any roughing on the external diameter of the brass. So in terms of machining, literally we're just going to cut this groove with a, I guess, either a 5/8 end mill or smaller.
Yep.
To get a 5/8 slot, and then we'll drill it and thread it with a tap.
We will need to use the lathe to face off the ends, though, to get it to the correct length.
We will and cut these
And then we'll
chamfers.
just do the slight chamfers on there. And then that's all we'll need for the lathe. Then after that, we'll go over to the mill.
Mm-hmm.
And how do you want to approach the threading in the hole?
We will cut our slot, then switch to the, I think you drill with a 29/64 drill bit for a 1/2 thread.
That's correct.
So we'll drill however deep we decided.
And now let's take a look at what we want to do for the handle. So this is going to be aluminum.
Naturally.
And there's going to be a whole lot. This is going to be mostly on the lathe, right? Do we need to do anything on the mill for this?
The operation you're going to observe now is called turning. It's done on a machine known as the lathe. At the simplest level, an old-fashioned manual pencil sharpener is basically a lathe. You take the workpiece and you rotate it at a high speed while the blade remains constant. The big thing to take away from lathe operations is that they are classically used for machining cylindrical objects. Next, you're going to observe another classical machining operation known as milling. At the very simplest level, a lawnmower is a milling machine, where the blades turn at a very high RPM, and then the workpiece or the lawnmower is fed across the grass slower. Milling is predominantly used for machining flat surfaces and or drilling holes.
Well, that looks pretty good.
Yeah, how do you guys feel about our final product?
I think we did a pretty good job. It's pretty accurate to the blueprint that we came out with.
Yeah, it ended up pretty much exactly like how we drew it on the board.
Do you want to take a couple measurements to see if it's turned out?
And I'll sit tidy.
Oh, it's about 1.1 inches.
So to quickly review all the steps we've just witnessed, we started with somebody having an idea or a concept, and then they materialized that concept by putting it on paper, by creating a draft or a drawing, and then it was reviewed by a team, co-workers, and it was further refined and improved on, and even finalized to some extent, and then that draft was put into a CAD system to create a 3D model. And from that 3D model, things got a little more formalized, and people started to like it and approve it, and then that became a blueprint drawing. And blueprint carries with it a lot of details and different degrees of difficulties depending on what you're trying to make. And then that blueprint was the starting point of conversation with various teams who are responsible for producibility of that concept. And then once the blueprint was finalized, an NC program was created, the correct machines were selected, the correct materials were purchased, and then we took steps towards producing the part. After the part was produced, there's one more step, which is you have to make sure that it was made correctly, and that was processed by way of inspection. And again, everything that we produced, everything we inspected, everything we originally conceptualized was all formalized by the blueprint drawing.